Now let's see the IP address. It's very important for the network device and for the terminal to add the IP address information into the packet, and then we can follow the traffic according to the IP address information. So about the IP address, usually we will divide the IP address to become two parts. One is network part and another one is a host part. And it totally has 32 bits long. Usually we will use dotted decimal way to indicate the IP address. Someone maybe say the IP address like 192.168.1.1. So this is the dotted decimal format. And about the IP address, we usually will have four parts. And each part it is 8 bits long. And about the binary, the maximal value means each one will become 1. About binary means the value to be 0 or 1. And the maximal means each part 32 bits long, all of them to become 1. So how to calculate from the binary to become decimal? There is a format. Let's see the detail. For example, now I take one part and 8 bits long to calculate from the binary to the decimal. And about the 8 parts from the right to the left, the sequence number is 0 to 7. Pay attention, in the network, the beginning value will become 0 in lots of scenarios, not about 1. So there are 8 bits, but the value will become to 0 to 7. So the next step, the formula is m and multiply 2 to the power of n, and the m is the number of the binary, 1 or 0, and the n means the sequence number. From the right one is 0, from the left one is 7, and in the middle maybe 1, 2, 3, 4, 5, 6, something like this. And then the next step, we will use this formula like 1 multiply 2 to the power of 7, and the last one is 1 multiply 2 to the power of 0, right? And finally, this result is a decimal result. So from right to the left, the result is 1, 2, 4 until the 128. And how to get the decimal? We have to plus 1 by 1. So the result will become 255. This is the biggest number of the IP address. Pay attention. Maybe in the future when you do the practice or maybe do the project in your network, you cannot create the IP address like 300 or 400 or 1000. No, the maximum number is 255. That's the limit of the formula. From the right to the left, the highest number is 7. So after that, if we plus 1 by 1, the maximum number will become 255. So let's come back to see the IP address. Now if we use a maximal binary, that means 4 parts. Each part we have 8 bits long, right? And each bit will become 1. The result will be 255, 255, 255, and 255. So that's the result. This is a maximum decimal number. And then we can see an example here. For example, now the binary like this. The first part is 11000 and the last part is 0111011. So how to get the dot decimal result? How to get the IP address like we see in our computer or in the device? We can use the formula. From right to the left is 0 to 7, and the result is 1 multiply 2 to the power of the 7, and then 1 multiply 2 to the power of 6, right? And if the value is 0 multiply everything will become 0, so I directly skip it. So each part we can use a formula to get the result, and then we can change it to become 1 by 1 to be plus all together. The result is 192.168.5.123. So this is an example of the IP address, how to calculate it and how to get the result. And usually we do the configuration of IP address, we will use the last example like 122.168.5.123. So this is an example. And in this scenario, we will find an IP address can be divided to become two parts. One is network and another is host. So what's the function of the network ID and the host ID? Let's see. About the network and host IP address, we usually have different meaning. The network ID identifies different IP network. For example, in this topology, we have one router to connect with two segments. In the different segment, the network ID will be different. So we can indicate the segment 1 or segment 2. And then in the same segment, we also have different terminal, right? For example, about the left one, we have the first computer, the second computer, and the third one is the interface of the router. Then how to distinguish different terminal in the same segment? This is a function of the host ID. So the host ID will identify an IP node on the network. So within the same segment, this terminal have the same host ID but the same network ID but different host ID. But in different segment, they will have the network is different, the host also is different. So about the router, we usually will use the network ID to indicate different segment. For example, here we have two sites, right? 192.168.1.0 and the interface is Zigbee 01, and another segment is 10.0.0.0 and the interface is Zigbee 02. So this is a function of the network and host ID. And another question is how to define which part is network, which part is host ID. So who gives the definition? And why about the router? The left one network ID is 192.168.1.0, but the right one is 10.0.0.0. Because on the topology, the gigabit of gigabit 2, the IP address is 10.10.1.254, right? Why the network ID to become 10.0.0? So this also is a question. At the beginning, how to define the IP address? What's the length of host ID? What's the length of the network ID? We have do the classification, and the IP address at the beginning is divided into 5 parts: class A, B, C, D, and E. In different class IP address, we have different lengths of the network part and the host part. So let's see one by one. What's the definition and why in the last picture the segment ID y is 10.0.0 but the other one is different. So about class A or class B, all the length is same. We have 32 bits long. The sequence number from 0 to 31. And we also divide the IP address to become 4 parts. Pay attention about the class A. About the class A, we directed to give the definition. First 8 bits to become the network part, and the rest 24 bits is the host part. And another definition is the first bit is fixed, is 0. This is the definition of class A. So according to this one, we can directly get the range of the class A, right? How to get the range? Get the smaller value and smallest value and the biggest value and calculate the result. Then we can get the range. The smallest range means all the bits to become 0, right? So the smaller one will become 0.0.0. What's the biggest? Biggest means the rest of to become 1, because the first bit is fixed is 0, so the rest 31 bits to become 1. get the result is 127.255.255.255. So this is a class A range from 0.0.0 to 127.255.255.255. This is class A. And then about the class B, it's a little different. We define the first 16 bits to become network part, and the rest 16 bits to become host part. And the second rule is the first 2 bits to become 1 and 0. Okay, so what's the range? Also, if we want to calculate the range to get the smallest one and get the biggest one, right? Smallest one means except the fixed 1 and 0, all the rest to become 0. This is the smallest one. And the biggest one means except for the first 2 bits, all of them to become 1. This is the biggest one. So the range will become 128.0.0.0 and 191.250.250.250. So this is class B. And about the class C, we will define the first 24 bits to become the network part, the last 8 bits to become the host. So the same principle to get the range is from 192.0.0 223.255.255.255. So this is class A, B, and C. And the next part is class D. This range usually will be used in the multicast scenario. So maybe you only know the range 224.0.0 to 239.255.255.255. This is a range belong to the multicast. It's enough for you because maybe in the next course we will talk something about multicast. And the last one is class E, and the first 5 bits is fixed, but this range is reserved, not used for the network. So about 5 classes, we have different range, and we have different lengths of the network and the host. And about the class A, B, and C, usually used in the network, and we can assign the IP address for terminal, we can assign IP address for the network devices, something like this. In class D, usually if you have the service of the multicast, we will use this address. And this is the different classification IP address. And another one, pay attention, in this address, we have some special IP address cannot be used. Pay attention. The first one is a network address. So what means network address? Network address means your network ID part. You can be used any value, but the host value should be 0. So this is the definition of the network address. And what's the purpose of this IP address? This one usually will indicate one segment. Okay, so do you still remember the topology? We have 2 interfaces, 2 segments of the router, right? In each interface network address, we use them to indicate the segment. And finally, this segment will be added into the IP routing table to help the router how to forward the segment from one side to another side. So this is a network address, cannot be used for the customer. And another one is a broadcast address. The definition is network ID, you can use any value, but the host value to become all 1. This one we call is broadcast address. And this one will indicate the special segment or node. Okay, so this is a broadcast address, cannot be used. And the third type is the loopback address. Only be used on the local. The special one is network part to become 127, and host can be any. About this part, pay attention. All the segment or the IP address cannot be used. Maybe someone says local address already, 127.0.0.1. Maybe when you open your computer have to detect the communication, the hardware can work normally or not. We will directly use this address to do the test. Okay, because maybe when you open your computer, you never get an IP address before. And the last two address means 32 bits or 0 and 32 bits or 1. 32 bits or 0 indicates the default root. So when we talk about the routing information, we will use this one. 0.0.0.0 cannot be used. This is indicates the default root. And all 0 means 255.255.255.255. This is a broadcast, indicates all node, not one special segment, all node in our network. So this IP address cannot be used for router, for switch, or for terminal. Okay, pay attention about this one. So let's come back about the IP address classes. Class A, B, C, and E, right? According to the definition, we already gave the range. And then we have to delete the special IP address cannot be used for the customer. So the different one is Class A. The correct range is from 1.0.0.0 to 126.255.255.255, right? Because the 0.0.0 all the segment we will use in the default root. But about the segment of 127, it is indicates the local address. So this one cannot be used. Okay, pay attention about this one. And then next we have to know how to calculate the number of IP address. Because we found the class A, B, and C, we have different lengths of the network, and we also have different lengths of the host, right? So what's the difference? If the network ID is longer or the host ID is longer, what's the difference? Let's say this one. The number of IP address. IP address is divided into two parts. The first is network segment and another one is host ID, totally 32 bits long, and the total length is fixed. And then if we make the network ID to become n bits, and the host ID to become n bits, of course, n plus n is fixed 32, right? The network number n, which will determine the number of the different network segment. What's the meaning? Pay attention. Maybe you have the company, right? And in your company, you have 3 departments. So you want these 3 departments, we can have different IP segment. And how many IP segment, how many departments you can use, depends on the n. If the n value is bigger, you can have multiple different segment. But pay attention, if your n value is bigger, your n value will be smaller because n plus n is fixed, is 32. So pay attention about this one. How to calculate the network number, how many segments we can use? The formula is like this one. Number of IP segment, 2 to the power of n. That's the n will decide how many network segments you can use. Okay? And now if you want to know within the fixed segment how many hosts you can use, because the host ID determine your network how many terminals you can have different host ID and then to get the IP address. This one is determined by the host number n. And the formula is 2 to the power of the n. That means if your n value is bigger, your n value will be smaller. The same one, if in your company you have 3 segments, right? You have 3 departments. And if you define the total segment to become 8, that means you can have 8 different IP segments, and each range, each department, you can have the IP address is 2 to the power of 24. But if you define the department different IP segments to become 16, you will have lots of different segments, but each segment, the host number is smaller than the first one. So this is different. Okay, but pay attention, the number of available IP address. About the available IP address, we also call host address. That means this IP address can be used for the devices. The formula is 2 to the power of n and minus 2, because what's the 2 address? One is network address and another one is broadcast address. These 2 address cannot be used in your network, so you have to minus this 2 address. Pay attention about this one. Okay, so this is a function of the IP address, how to define, how to give the IP address, how to what's the format, right? And we usually see the IP address like 192.168.1.1 or maybe 10.1.1.1, something like this. That's because this is a definition of the format. And pay attention, different network lengths or different host lengths will have different influence. The host ID will define how many IP addresses can be assigned for the terminal or for the network device. And the length of the network will determine how many network segments you can use. So now if we already know how to give the IP address, what's the format, then let's see the detailed process. How to use the IP address, what's the protocol we usually in your network, and what's the function. Let's see the next video.